A bag has 5 blue marbles, 4 green marbles, and 7 red marbles as pictured here below. Notice how we have a total of 5 plus 4 plus 7, or 16 marbles in the bag. For number 1, you select 2 marbles one at a time with replacement, which means you select one marble, look at the color, replace the marble back into the bag, and then select the second marble. Determine the probability the first marble is blue and the second marble is also blue. So if we let B equal the selection of a blue marble, we can say the probability is equal to the probability of B and then B again. And because the first marble is selected and then replaced back into the bag before the second marble is selected, the outcome of one event does not affect the outcome of the other, and therefore the two events are independent. Independent events are events where an outcome of one event is not affected by the outcome of the other event. And if events A and B are independent, then the probability of both A and B occurring is equal to the probability of A times the probability of B. So in our case, the probability of B and B is equal to the probability of B times the probability of B, because the events are independent, because we are selecting marbles with replacement. And now to determine the probability of B, because 5 of the 16 marbles are blue, the probability of selecting a blue marble is 5 out of 16, or 5/16, which gives us 5/16 times, again, the probability of selecting a blue marble is 5/16. So we have 5/16 times 5/16. Nothing simplifies, and therefore multiplying, we have 25 256, or 25 divided by 256. Let's also express this as a decimal and a percentage. To 4 decimal places, the fraction is approximately 0.0977, which is 9.77%. And now for the second example, you select 2 marbles one at a time without replacement, which means you select the first marble, do not replace it back into the bag, and then select the second marble. And we're asked to determine the probability the first marble is blue, and again, the second marble is also blue. So we want the probability of a blue marble and another blue marble, but now without replacement. So because the first marble is not replaced back into the bag, the outcome of one event is affected by the outcome of the other, and therefore now we have dependent events, where dependent events are events where an outcome of one event is affected by the outcome of the other event. And the probability that event B occurs given event A has happened is represented using this notation here, which is read, the probability of B given A has occurred. So if events A and B are dependent, the probability of both A and B occurring is equal to the probability of A times the probability of B given A has occurred. So again, for our example, because we have dependent events, the probability of B and B is equal to the probability of B times the probability of B given B has occurred. So we know from part A, the probability of selecting a blue marble is 5/16. But in this case, a blue marble is selected and not replaced back into the bag before we select the second marble. So let's just say this is the first blue marble selected. Because it's not replaced back into the bag, now we have a total of 15 marbles. And now only 4 of the 15 marbles are blue, and therefore the probability of selecting a blue marble, given a blue marble has already been selected and not replaced, is 4 out of 15, or 4/15. So notice how the number of favorable outcomes has decreased by 1, and the total number of marbles is also decreased by 1. Before multiplying, notice how we can simplify. There's a common factor of 4 between 4 and 16. There's 1 4 and 4, and 4 4s and 16. There's also a common factor of 5 between 5 and 15. There's 1 5 and 5, and 3 5s and 15. Multiplying, the probability is 1/12. So the probability of selecting a blue marble and then another blue marble without replacement is 1/12. Let's also show the decimal in percentage. To 4 decimal places, 1/12 is approximately 0.0833, which is 8.33%. I hope you found this helpful.